This conference will now be recorded.
So my name is Tara Theory, and we're just doing a quick sound check. Can everybody hear me? Is this okay? Good levels? Great. Okay, so the name of my presentation is Striving Beyond Surviving in Pursuit of Perpetual Learning, and these are excerpts of lessons from Barbara Oakley's A Mind for Numbers. And the reason I got into this and into this book is constantly looking to improve, like quickly. It's like I've been studying for a long time, it seems like, and I wanted to know how to be more effective. And I understand now that there are ways that the mind works that wasn't necessarily explained to me when I was like studying in traditional places. So I understand that there's like performance psychology, there's all kinds of new approaches, and this book is talking about that. Again, it's Barbara Oakley's A Mind for Numbers. So first thing is that there are two modes of thinking. Focus mode, which is essentially for studying math and essential for studying math and science. It involves a direct approach to solving problems using rational, sequential, and analytical approaches. Second mode that she talks about is diffuse mode. Diffuse mode thinking is what happens when we relax our attention and just let our minds wander. Diffuse mode thinking is also essential for learning math and science. It allows us to suddenly gain a new insight on a problem we've been struggling with and is associated with big picture perspectives. There are two major memory systems that she talks about. First one is working memory, which is like RAM. It's the part of memory that has to do with what is immediately and consciously processing in mind. It's now widely believed that working memory holds about 4 chunks of information. Long-term memory is like hard drive space. It's a storage warehouse. Items in there generally stay put and can be difficult to retrieve. Long-term memory is where we store fundamental concepts and techniques. One needs to revisit a few times to increase chances of being able to find it. So I want to go back to the modes of thinking. And one example that I thought was really salient was when she talked about testing.
Hey Tara, your slide's not changing, by the way.
Okay. Oh, wow. Okay, sorry. So here's modes of thinking: sequential and analytic, diffuse mode. So to use focused mode, we would go through the test and look at all the questions, get the lay of the land, as it were. And her suggestion is to hit the hard questions first. And the reason for that, and I mean, just like to, okay, we'll work on it, and when it gets difficult, to move to the easy questions. And the reason for that is to allow the diffuse mode to kick in, right? So while we're working through the test, it's a consistent, the mind is still working, but focusing on the easy stuff. And it's like, that's one example of using both. One example of using both sides to our advantage. So we talked about working memory, long-term memory, and now for the importance of sleep. One of the major takeaways for me with this book was that one learns early. We can't, with developing the kinds of structures that we need in terms of changing our mind structures and changing to adapt to the type of knowledge that maths and sciences and technology can include, it requires a lot of time but working both the diffuse mode and focus mode thinking. So it's important to think in terms of process and not just product. So the importance of sleep. Sleep is vital in memory and learning. Being awake creates toxic products in the brain, and prolonged sleeplessness is lethal. During sleep, cells shrink, causing space between cells, allowing fluid to wash past and push toxins out of the brain. Sleep keeps the brain healthy. Sleep erases trivial aspects and strengthens areas of importance. Sleep rehearses some of the tougher parts of material, strengthening neural patterns. Sleep makes a remarkable difference in figuring out difficult problems and finding meaning and understanding in material. Going without sleep the night before an exam can mean, even if perfectly prepared, the mind is unable to function properly. The next section she talks about is, or what we're going to talk about, is chunking. Chunks are pieces of information that are bound together through meaning. The complex neural activity that ties together our simplifying abstract chunks of thoughts are the basis of much of science, literature, and art. Chunking is the mental leap that helps unite bits of information through meaning. One of the first steps toward gaining expertise in math and science and technology is to create conceptual chunks. How we can create conceptual chunks is to, first of all, focus attention on the information we want to. Two is understand the basic idea. Develop a solid expertise by reviewing soon after the first aha or learning. Self-test by recall, also known as retrieval. This will speed learning. And three, gain context. Practice helps broaden networks of neurons connected to chunk, ensuring the chunk is firm and accessible from many different paths. Illusions of competence. Glancing at a solution to a problem and thinking one knows it is one of the most common illusions of incompetence in learning. The antidote is to work the problem using recall rather than passive rereading. And this was William James. He was a 19th century philosopher, American philosopher and psychologist. And I'm just going to read this because again, it's like the information getting information about how the mind works has been a study for a long time. So a curious peculiarity of our memory is that things are impressed better by active than by passive repetition. I mean that in learning by heart, for example, when we almost know the piece, it pays better to wait and recollect by an effort from within than to look at the book again. If we recover the words in the former way, we shall probably know them the next time. If in the latter way, we shall very likely need once more. Hi. So if having trouble grasping, try to remember and understand how the originator arrived at the idea and why it is used. Practicing and recalling material are most efficient at attaining deeper level of learning than any other approach. And this is something we've heard Tam talk about. Persist information into master material well, and think creatively. The ability to combine chunks in novel ways underlies innovation. Imagination is fueled by breadth of interests. Again, we see this with how women in Linux present so much information, so many different ways to be active in technology. So there are two ways to solve problems. Focused modes, sequential by-step processing and reasoning. And then there's the holistic insights that intuitively arrived at, which aren't always correct, to be verified. With chunked libraries, we can recognize specific problems as well as different types and classes of problems. Procrastination. We procrastinate about things that make us feel uncomfortable. The dread of doing a task takes up more time and energy than doing the task itself. Procrastination is a habit that may influence important areas of life. Interestingly, habits conserve energy, allowing mental energy to be applied elsewhere. If we can change the habit of procrastination, other positive changes can begin to unfold. So looking at procrastination as a habit, we're looking at specifically at habits or habit formation. So there's the cue trigger, the routine, which is the habitual response to the cue or the trigger, the reward, for example, moving focus to something more pleasant, and then the belief, conscious or unconscious, that a habit benefits us. It might be immediate gratification of belief. So in terms of looking at procrastination and habit formation with the cue trigger, this is the only place we actually need to apply willpower, because we really want to conserve our energy as much as possible. With a cue or trigger, protecting helpful routines with the habitual response becomes really, really key. And the reward, for example, for moving focus to something more pleasant regarding good study habits is a way to escape a negative habit or an unhelpful habit. And again, the belief, conscious or unconscious, that a habit benefits us. So to change a habit, we need to change the underlying belief. Say, for instance, using mental contrasting, current versus where we want to be, can be the engine that drives changing unhelpful beliefs. Preventing procrastination, focus on process, avoid concentrating on product. She recommends the Pomodoro technique, which is setting a timer and using focused mode thinking to work that time, short time, 30 minutes, 20 minutes. And that helps get consciousness back on track. If we learn under mild stress, we can handle greater stress more easily. Ignore distractions, then practice ignoring distractions. And we should note that multitasking siphons off energy. Multitasking does not allow the firming up of neural connections, which is really key in terms of developing chunks. So, tools, tips, and tricks. We trick ourselves into doing what we ought to be doing. To a great degree, the highest performing people I know are those who have installed the best tricks in their lives. The smart part of us sets up things for us to do that the not so part responds to almost automatically, creating behavior that produces high performance results. And that was from David Allen. Make use of the generation effect, Jeunesse, recalling material which helps learn more effectively than rereading. If pressed for time, use a few key problems as a form of deliberate. Make use of self-implementation and recording activity outcomes. Use a planner, journal, personal lab notebook. An effective task list system frees 4 slots of working memory. It's important to have an end time, which I did not realize. And so set up a reasonable end time. And it's amazing that there's productivity, how much productivity kicks in. It's like the mind. It's like it's a loop, a reward loop for the mind, or for our whole being, actually. Embrace befuddlement. It's a healthy part of the learning process. And we're speaking about mental contrast again. Again, it's where you are and where you wish to be. Be aware that knowledge collapse can happen with minds restructuring its understanding. This is part of the process of assimilation of new knowledge. Articulating the question is 80% of the battle. And then there's some rules of bad studying that she gets into. 10 rules of good studying. I'll go back over that. This is the book. Here are some tools that I found as I've been learning and trying to sort of integrate new knowledge that I've been finding very useful. In terms of using recall, there's the idea of space repetition and using flashcards for that. So especially the major concepts, to repeat those in a spaced repetition manner. And there are a number of resources for that. Anki is an open source one. Quizlet, Brainscape are some other good ones. And in fact, in these different formats, people have developed, say, Linux decks or decks that are useful for those of us that are working on programming. I just also found out about raindrop.io, which is a bookmark manager. So if I go to a Medium article, I can bookmark it, and I can actually read it in Raindrop. It's available on all of the browsers, on the major browsers, and it's like that gets past the Medium paywall, which I didn't know about before. And another one that's really cool is YeNotes, or also known as Turbo Notes. Again, it's available for the major browsers, and that offers note-taking, time-stamped video note-taking. And these are some other ones. And this is, I think, something that is very, quote from Octavia Butler that's very useful from Parable of the Sower. All that you touch, you change. All that you change, changes you. The only lasting truth is change. God is change. It's kind of my mantra, and I think very appropriate for those of us working in tech. And here's my contact information. And if anyone has any questions or whatever, let me know. And I'm going to get out of sharing my screen now.
Thank you, Tara. Anybody have any questions? Need to get the book or anything? And I'm looking in the comments too, in case people are typing.
And if we start recording here, and then
hold on one second.
This conference will now be recorded.
All right, starting off with a recording. Okay, so here's a little tidbit of information that you never probably even thought about. You see these dots at the end of each one of these lines here? Do you know what those those dots mean? Those periods, do you know, you have an idea?
No.
No, so what those dots mean is that SE Linux is enabled and turned on is enabled on the system. That's what they mean.
Okay.
All right. Okay, so by looking at these permissions, what's this first? What's this one here? Who? What are these two? What are they?
It's the
User.
user and user group.
Okay, and then this is the actual file or directory or whatever the case may be. All right. And we know that because we have permissions here that tell us D for directory, nothing in the front here, nothing in the front here or here. So they must mean they're a file. If they were a link, it would be a L in the front. We know that the permissions are 664, meaning user group other UGO. UGO equals to 664 on L file 1. And then,
664?
yeah, right here.
Oh, the second one. Okay.
Yeah. 664. Here we know that is 646, 664, and then 640. You got that?
Yeah.
Everybody got that? If you didn't get it, let me know.
Yes.
Okay, we're gonna keep it pushing. All right. So the first question is, which regular file is owned by operator 1 and is readable by all users? So the question is, which regular file is owned by operator 1 and is readable by all users?
R file 1.
R file 1 is your answer? Everybody agree with that? I'm getting some yeses, and that's the right answer. All right, the next question is, which file can be modified by contractor 1 user? The contractor 1 user, which file can be modified by them? Oh, sorry, cannot. Sorry, cannot be. No, that's right. Which modifier can be? Sorry, I'm looking at the wrong question. Modified by contractor 1 user.
L file 2.
Everybody else pitch in. What you thinking? Somebody say R file 1. So let's go over this question. It says, which file can be modified by contractor 1 user? Which file can be modified? So modified meaning you can write to it. So we're gonna automatically can be modified by contractor 1. So is contractor 1 in the group? We don't know. So we have to go with the other. So I'm going with 2. I may be wrong. Which file can be modified by contractor 1? Contractor one doesn't own anything up here, so we gotta make this, I guess we gotta make the assumption that the contractor is in the other. Or they may be in the group. It could be either or, but I'm going with other.
Mm-hmm.
So let's see what the answer is. The answer is L file 2. You understand how I came up with that?
Mm-hmm.
So how I came up with that is we know that is user group other. So that's equal to user group other. That's what UGO stands for. So we know that the contractor is a user, so automatically it's not a user because they tell us here. And the groups are here. So based upon what they give us, I'm not gonna, you can make assumptions, but they don't give us that. They just give us that these are the groups. So the only other thing that's left that would make sense is that they're a part of other. And write gives you a chance to modify. Execute just gives you a chance to run. So it had to be some write permissions on there. So that's how L52 became the answer. The next one is which file cannot be read by operator 2 user. Operator 2 user. Which file can it not read? So we need to look at things that eliminate read permissions, and the only thing that eliminate read permissions is what? This one?
Uh-huh.
R file 2. So let's go and check. That is correct. All right, we have 3 more questions. All right, the next question is, which file has a group ownership of consultant 1? Group ownership.
The first one. L file 1.
Everybody agree with that? You know how she got to that answer? Explain to us how you got that answer.
Well, consultant 1 is the group user of that file.
So this is how you
Yeah.
explain that.
Okay.
So how you explain it is you recognize that the user is consultant 1 and the group that file belongs to is consultant 1. And so you realize that the group ownership is consultant 1. So therefore that consultant 1 is L file 1. So that's the answer. That's how you came up with that.
Okay. Thank you.
You're welcome. That's what helped you determine that. What files can be deleted by operator 1?
Nothing.
What say you?
Oh, wait.
Yeah.
Oh,
What
the first.
files can be deleted? So when you think about delete, what do you think delete is? Is that a write or an execute?
Execute.
Okay, so now it is what has an execute permission?
The first file.
Is it a file or is it a directory?
Directory, sorry.
It's a directory. So the answer is what? We're looking for a file that can be deleted.
Would it be all the files within that directory?
Would it?
Wouldn't it be, is write permission the same as delete permission?
Is write permission the same as delete permission?
Or, yeah.
Mm,
If I write to something, does that mean I can delete it?
no, I think you could just write to a file, and delete would be an execute.
Okay.
You want to know what the answer is?
Yes.
Mm-hmm.
All of the above. That's the answer. Which files can be deleted by operator 1?
Are we assuming the files are in the directory owned by operator 1?
No, they're not assuming that. Says operator 1 is in groups, operator 1 in database. I guess I should give you that.
Oh.
What?
Mm,
Oh, okay.
Operator 1 is in groups, operator 1 in database. So operator 1 is in this group here in database 1. Because they're in database 1, they can do what they want for that. They can't do nothing. Well, they can do that. They can do something here, but they can't do nothing.
So it looks like they own, but they own the directory then, right? Operator 1?
No, they don't own the directory, but they're in. Operator 1 is in. Oh yeah. They don't own the directory, but operator 1 is in operator 1 and database 1 directory. In group, so they can do everything.
Okay, I'm confused. I'm sorry, Pam.
Me too.
Operator 1, the user, is in the group operator 1 and database 1.
But how am I going to know that if I don't?
I didn't tell you. I didn't tell you.
Okay.
Okay.
Gotcha.
But
now I know.
Yeah, but now you know.
Okay, thank you.
But do you see that? No.
No, I see it now that you communicated. Operator 1 is in the database. It's part of that. If I'm saying that right.
All right, let's give you one more. That's all we got is one more. All right. Operator 2 is in groups operator 2 and contractor 3. You got that? Operator 2 is in the groups operator 2 and contractor 3.
Okay.
You got that?
Yes.
And the question is, which files can be deleted by operator 2? Operator 2 is in contractor 3 and operator 2 groups. Tune said none of these. Operator 2 is the one doing deleting. And operator 2 is in the group operator 2 and contractor 3.
What was the question again?
What files can be deleted by operator 2? Tune said none of these, and the answer is none of these. Because operator 2 is in the operator 2 group and the contractor 3 group. And that's not on any of these. You follow that?
So I was thinking, but I didn't want to say it out loud. I'm like, we don't have enough information. We don't have the time.
You gotta be sure. Oh,
That's
if
true.
you want sure, you know, you could spin up your instance and make these directories, and you can make these files.
That's true. I'm getting there.
So, therefore, none of these. Did that make sense?
Yes.
Okay. So let's go over some stuff real quick. All right. All right. So if I do this, what is that? What is that going to do?
It's gonna change the permissions of file 1, no?
Right, but what is it going to do?
Go,
Group and other cannot read or write?
It's going to take away the permissions
Yeah.
yeah.
of read and write. So right now the file has read and write on user, group, and other. And so on group and other, I'm going to take away read and write permissions. So what should the outcome be on file 1?
So read, write, execute for the user
If I'm taking away read and write permissions, they
The
go away
permission,
from the group and other, right?
from the group and the other.
So the user can read, write, execute, no?
Where are you getting execute at on file 1?
What?
Where are you getting execute from on file 1? There's no execute permission set.
Okay, I'm just going by the LL line.
So right here. Yeah,
What?
so right here on file 1, what are the permissions?
Oh, that file. Sorry. Okay. So read, write, and then execute, and then
Where's
execute.
execute? Where's execute at?
No. Read, write, and then
Read, write,
read,
and
write, dash.
okay. So now when you look at it, your file 1 is this
Yeah.
because I took away read
Okay.
and write from that particular permission. I mean, from that particular group and that other. It didn't have write anyway, so it just took away the read. So it left me with read, write. Does that make sense?
yes.
Right. There was never any execution set.
No. I was assuming like I wasn't even looking at those files,
Oh, okay, yeah.
like an imaginary file.
No. I got it on the
Okay.
screen.
Yeah. All right.
Go back to LL. So now let's do Chmod A plus X on let's do it on file 1. So what should I get now? What does the A stand for? The A stands for all users.
So you're giving all users the permission to execute?
Yep. So what should be the permissions after we finish with file 1? Right now it's 600.
711?
Yep. You see that?
Mm-hmm.
Then everybody catch that. Did everybody catch what just happened? Now, the other way you do this, you could just do chmod 711.
Yeah, because I'm good with the numbers.
Uh-uh. You gotta learn them all kind of ways. Right? So that's how that works. So you can let's play around a little bit more. Let's make sure you know what you're doing. So let's do chmod A plus R on, no, let's do A minus, no, let's do O minus R on wow. All right, so what is file gonna be now? If I do an O minus R on file,
Read, write, read,
212?
and dash, all dash.
well, I'm only doing it on other, so
Yeah, so 660.
just like that. Let's do another one. What's gonna be the outcome if I take away execute permissions from group and other? That's how you should read that. I want to modify permissions on group and other by taking away execute permissions on file 1.
700.
Are you getting the hang of it now?
Mm-hmm.
Okay. Let's test theory. What's gonna be my outcome on hello?
777.
Any other takers? Say tune they got 777. 777. It's the same thing as same thing. Just gotta understand how things are written. So when you see that on a test, somebody quizzing you, you should be able to recognize these things, right? So I'm just gonna throw some stuff on a screen. And I want y'all to tell me what these permissions are. Let's go back over this again. We're gonna drill this in. All right, so I hate when it does the capitals, but it's okay. Come on. I know how to do this. We'll do. We'll divide this up. So it doesn't overwrite it. All right, so what would that permission be? Never mind the separations. I just had to separate them out.
1.
631.
You said 6 what?
31.
Everybody agree with that? Okay.
Mhm.
All right, cool. One more.
W, that's 4. No, that's 4, that's 5. 0, 4, 5.
305.
What'd you say?
305.
No, that's not it. 3, yes. Yes.
You sure?
Yes.
Okay. We're just adding and subtracting here. All right. Got that down. I think y'all have that down. I think you got permissions down. I think. All right, so here's where here's where it gets tricky. My favorite are these guys. So this is actually wrong. Let's do this. That goes with that. That goes with that. And this goes with that. That's what that's supposed to be. And I'll explain this in a minute. All right. So we have these permissions called SUID, SGID, and sticky bit. Of course, you know the infamous directory that has a sticky bit on it, and that is temp/temp. So if you went over to, /temp, but let me go up one. And let me clear my screen. Do ls -temp. You see, well, excuse me. If I do a ls -l, you see on my /temp directory, I have a sticky bit set there. That T is the sticky bit. And if you look at all the other directories, you don't see a sticky bit set anywhere else on any directory. But you do see it on temp. And so they're telling you right here, sticky bit has really no effect on the files. That's what they're trying to say. So this is on files, and then effect on directories. The third sentence is users with write access to the directory can remove only the files that they own. They cannot remove or force save to files owned by other users. So that's why I'm always in /temp. So if you, let's see if on my Mac it has it. Should have it on my Mac.
Where's response here?
Let's see. Do I have a temp in here? I have a temp directory on here. Let's see. Temp. I don't think I have one on here. Sure. Yeah, I thought I did. CD up. Oh, there it is. See, temp. It don't have a sticky bit on there. So this is on my Mac. You can check your Mac to see if it got a sticky bit. But in Linux, in RHEL, and I think in Ubuntu, there's a sticky bit that says.
How can you tell if there's a sticky bit I'm sorry, what are you?
Right here. That T. That T right there.
Oh, okay. Thanks.
The T told me there's a sticky bit, and that sticky bit has no effect on the files. So on /temp, the sticky bit, that way has, and I need a Y right there, has no effect on the files. Okay. So what they're saying is, if I have another user in here except for root, I can't erase Tamika's file. So user at Tam. Oh, it's already there. All right. So let's touch, let's SU and then CD over to temp. Who am I? And then let's do LL. Let's see if I can remove the file. Let's see. Operation not permitted. One of the reasons is I am not in the group, but also in /temp, whatever file gets created inside of this directory, it's always going to be owned by the person who created the file. And the same thing for, let's look at hello. Let's see if it'll let me remove hello. What do you think it'll let me remove it? It might. What are your thoughts? Can I remove it? Who says yes? I got all permissions. It's 777. Can I remove it?
Yeah. Yeah.
Nope. Operation not permitted. It's because of that sticky bit on the directory. The sticky bit, users with write access to the directory can only remove files that they own. They cannot remove or force saves to files owned by other users. Couldn't do nothing. And we just proved that, right? I got hello. Hello has permissions of 7777. Yeah, only my files that I own. Now, if I went and added myself to the sudoers, as root, I could probably remove that, but I know as super user, I can remove.
But
And
Tamika can remove me, right? And
nope,
huh?
nope. So who am I?
You're
I'm
Tam.
Tam. So let's touch Tam files and let's exit. Oops, I didn't mean to exit all the way. Let's go back in. And then let's go add me over to temp and try to delete temp files. And see what happens. What do you think is going to happen? So we have, where's my temp files? And then create it. All right, cool. Oh, there it is, right there at the bottom. Temp files. So can Tamika delete it?
No, I mean Tamika can delete file one and hello, right?
Yeah,
Yeah, yeah. Okay.
but I can't delete temp files. I can't delete them. And even if I sudo su-tam and then cd over to /temp and then give myself, I'm gonna make this 777 or a plus rwx on tam files Make sure we got it, right? All execute, all read, write, execute. So now let's exit that. Who am I? I'm Tamika. I'm in temp. And we got read, write, execute on 10 files. And I am going to try to delete 10 files. Can't,
Do not do, yeah.
right? That's what the sticky bit here does. Now, the question is, how the heck do you set that sticky bit? Well, this is that octo notation that I was talking about. Okay, so let's pull up a good example for this so you can see, because it's actually you would set on the directory 1755 on it, but let me pull it up. All right. Sticky bit set Linux. And let's pull this over. And the best way to learn sticky bits and so forth and so on is Red Hat's website or Fedora. But we'll go here. So to set a sticky bit on a directory, you change it to 777 gives everybody stuff, but I do 755. All right. You could do 777, but I'll show you that in a minute. Or you can just add the plus T to the directory, right? And you can see it added it to the end there.
Okay.
All right. So this one out in front that's where you're setting that you're setting the sticky bit there, right? If it was Chmod I think 2. Is it 2? I gotta go get my numbers because there's a list on what sets the UID, the GUID, and the SUID. And what I'm saying is this: what they have here, SUID and GUID. And then this one right here is the one we just did. It's just sticky. And this is normally an interview question. Okay. All right. So now to set the sticky bit, example would look like 177. That's an example. Or chmod plus T, right? 1 on file 1. Oh, I mean, dir 1. So let's go on dir 1. All right. That's what you would use to set the sticky bit. Okay. You got it? All right. Now the set UID this is the one that you do the 4 on. So let me put a 4 in here in parentheses, and then we'll come back to it, and then the 2 here. Yeah. All right. So what am I talking about? So the example would be if I want to set the SUID on a directory, it'll be 4777, or we're going to chmod this one. And then this one right here, example would be 277, or, and we're going to come back and do the chmod on that. All right. So now the chmod on this would be, because we want to do the UID, this is where we go in and we say U, is it capital U? No, G, and we'll get into that. I don't want to confuse y'all. I'm going right here, G plus S on a directory. So we'll say on dir 1. So that adds the sticky bit. And what do you think this one is? Well, yes, look it up.
U plus S.
Yep. under one. That's how you do sticky bits and group ID, group user ID, and set user ID. All right, so why do you care? All right, so you care for this. Oh, come on, screen. Trying to find my mouse now. There you go. All right, so here we say the file execute as the group that owns the file, but files newly created in the directory have their group ownership set to match the group owner of the directory. So anything after that in that directory is gonna always get set with the ownership of the, whatever the ownership of the directory is. Here, when we're talking about the file itself, and we're gonna run through an example of that, file executes as the user that owns the file, not the user that ran the file, no effect. So let's go look at some examples. Yeah, I want some more notes too, by the way, so you can really follow along with this. Let's go to Fedora, GUID, and SUID. Let's see. Oh, here's one from Red Hat. This was in 2020. Here, I'll put this in the notes. So let's go look at it. All right. Here is where they talk about the UGOA group, other all is who, the plus and minus, add and remove. We know that, and which read, write, execute. So you understand this right here, right? What is this doing? Right here.
User group can read write to
It's is adding the permission,
yeah.
not can, but adding the permission to read and write. And then they give you the numerical value of that, right? But here's the special permissions, right? This is special permissions make up a fourth level of access to user and group, and other special permissions allow for additional privileges over the standard 7777557666754, whatever. And then they like, let's break this down. All right, so they give you user bin password. So let's go look at user bin password on our system. Because what do we see here out of these permissions? What do you see that's different? You see the S that's on there, right? And this is what I was talking about. Then there's like, if the file owner doesn't have an execute permission, then the uppercase would be S. But because there's probably was an execute permission here on user bin password, it's lowercase. So let's go look at and see what it actually is on our system. All right, so let's go over to ls user bin. All right, and then let's ls minus l user bin, and let's grab password. You won't let me do that. Okay. See, who am I? Okay. Oh, I didn't grab. That's right. Okay, so here we have what do you think this is? What do you think this number is on this particular directory? What is the octal number on this? If it's set on the user and it is this GUID, it is 9 times out of 10, 2755. right? It's probably 2755. And how did I come up with that? Because the execute permission was probably set on this. So that's why it's a lowercase s. And then it turned into that we know what these are. So that's how I came up with 2755. Let's see if we can make the same thing. All right. So let's make a file called password. And we're in our temp directory. And then let's do an LL. And right now the file is 4 and 2, 664, right? So let's make it 755, right? So let's chmod 755 password, right? So now password is 755. But now let's change the permission to chmod 2755 on password. And now let's do an LL. So let's look and see. Did we do it wrong? Yep, because it came out on, oh, I'm supposed to do it on the user. Should have been 4. Let's go back. Change that to 4. Let's go here. And I may have to change that. Yeah, I'm gonna have to change. Okay, that worked. It was 4. My bad. I was looking at GUID. We need it on the UID. So we started out with making the actual we started out creating the file. Then we changed permissions to 755. What I should have done was did chmod 4755. And that's how you see that one, it started out with the execute permission it started out with an execute permission and changed it to an S, right? On that, and it gave us the SUID, and then it gave us read and execute and read and execute. So that's what this does right here. And what effect does that have? Well, the file executes as the user that owns the file, not the user that ran the file. And it has no effect on directories. So that's what these are right here. So what we'll do is take this here and put that here. Special permission, sorry. And this is special permission here, special permission here, and a special permission here. And then this part right here, effect on the files. I'm gonna drop that down to here. I'll put a colon there. And effect on directories, no effect. And that comes back up there. That's how that should read. Does that make sense now? Is that clear now? No? Yes? Still trying to figure it out?
Yes.
All right. Special permission, effect on files. And effect on directories. And it's kind of self-explanatory. So let's go through that.
So what's the use case for this kind of setup?
The temp directory is one. Another one is you want to, every time someone creates a file in the directory, you don't want to change the ownership of it. You can say then that person has I mean, you don't want to change the group ownership every single time. Every time they create a file, they'll be in the same group. That's what that is. Okay. And I can give this to you afterwards. Okay. So let's go back to our example. All right. So we figured out how they got their permission here, right? Let's do another one. Let's do another one. Well, I'll quiz you on it. All right. So automatically test has permissions of 664, but I want to make the permissions 755. So how do I do that? What do I type?
Shamad 755 test.
So I want to make them 755. Anybody? All right, Shamad 755 test. And then how you do that? That's what I want to make the permissions, right? Okay. So the next thing I want to do is I want to change the GUID on that file. So now if I want to change the GUID, I have to put the 2 in front. If I want to change the UID, the SUID, I change the with the 4, or if I want to put a sticky bit on it, I'd change it with the 1. And remember, the sticky bit has no effect on files, so it doesn't make sense for me to change it on a file, but it makes sense for me to change it on a directory. And up here, they talk about the effect on files. If I want to change file executes as the user that owns the file, not the user that ran the file. So if I ran the file and I have the ability to run the file, it's going to run as the user that actually owns the file, not me myself. All right, so let's go back over here. If I want to change it using the UID on this, the SUID on this, I should say, I'm going to do the 4. So I'm going to do a Chmod 455 on test. Now, what effect does that have? What is that? What is going to change? Does anybody know? See, same thing. Now, what if I do the 2 in front? What do you think that does? It acted upon the group. You see that? Now, here's a little trick. Let's let me show you what they were talking about. So let me do and then let's do a Chmod 764 on test. Oh, sorry, on test 2. So now on test 2, we did 764. Yep, 764, right? And we want to change. We're gonna change it on the group like we did before, or we did Chmod 764 on test 2. And then when we do it, oh, that's I did the wrong one. It should have been on the 2. Because I want to do the group. There's that big S that it was talking about. So in other words, what they're trying to show there is there was no execute permission set before,
Mm-hmm.
but you're placing a sticky bit there. So that's what you'll see that on some files if it's no execute permission there. Now this gets into some things. I know we're probably gonna have to go over this again tomorrow, but if you type in UMask, our UMask is set up in an octal format 002. So all permissions start out. I think files start out with 777, and I think that's how it works. Gotta look that up. Files start with 777, and their start with, I think they may start with 772. Don't quote me on that. I gotta look that up. So anyway, what ends up happening is whenever you create your files, you get this UMask that actually subtracts and gives you your numbers. So whenever you let's CD up, all right, and let me go to root. Yeah, I gotta be in root. I gotta be root without CD up. And then when I make a directory, make dir new dir, right? Let's do an LL on new dir. New dir now has permissions of 755. I think when you log in, I think by default, I think the UMask may be 00, it may be 022. But let's double check this in Etsy profile. Let me double check that. It may be somewhere else. Okay, yeah. So if your user ID is greater than 199 and user bin ID, and you can type this into if both of these match up, then it's gonna give you a UMask of 002. Other than that, it's gonna give you a UMask of 022. Right. So my UMask that I get is this. So let's go back and check what I'm getting now as I root to root. See, as root, I got a UMask of 0022. And if I exit out and do a UMask, I got a UMask of 00002. So that determines what your permissions on your directories are going to be. So what ends up happening is you start with 0777. Then because my UMask is 0002, that's going to give me 0775, right? And that should be my outcome on my directory. So let's check and see. So let's CD to home. And let's make a directory. Let's see what happens. I get a directory of 775, right? Because of the UMask. The UMask determines what my permissions are going to be automatically. Now, when you start locking down people's file systems, well, not file systems, when you start locking down when you start hardening your systems and following these standards, your UMass is going to change. It's going to change that for you. That's part of the thing. You never want to have a directory with all the permissions to world readable is what we call it. You never want to have that. Now let's see, who am I? Let's go back up. And let's go to my home directory, is root. And then let's make a directory here and do LL. And you can see it's 755, but my UMask is 022. So I start out with 0777 and then I minus 0022, and that gives me 0755. And that's how your directories get the permissions that they start out with. Let's test this theory for files. So the file is 644. So I think files start out with, they may start out with 666. So let's check and see. 0666, and the UMask is 0022. So then that means you would get 644. Yep. So the files start out with 666. And the directory start out with 777s. So that's how you end up with your files being the number that they are, right? If I go back down to my user as Tamika, and I do a touch on, if I just do a UMask, 0002, so I should be seeing 0664. So let's test the theory. And let's do an LL on hello me. I get 664. Make sense? Now, you ask when this is going to be appropriate on the test. It's when it's going to be appropriate. When would you use this in real world? You use it when your hardening systems, you want to set the UMask up. I think, let me look at NIST standards. Let me look this up. Let's look it up. NIST standards UMask is just one of those things to be compliant. I think it may even be on the Security Plus exam as well too. Does an audit here. Oh, they don't have the file. All right. Let's see. UMask. I only got it there one time. As a default result, APIs will create directories of 644. I mean permissions of 644 and directories of 755 respectively, unless the API fails safe. But there is a reason why the UMass has to change when you're on this, because they don't want directories with execute permissions and so forth. So then we start getting into, and I'm gonna go over this again tomorrow. I'm gonna give you some more examples. We start getting into ACLs and setting the ACLs and stuff when I say apples ACLs. So let me see if they got another example out here to help clarify some stuff for you. Set GID use case. Let's see if somebody has a use case. All right, so getting to know special permissions, how to identify knowledge and requirements, special permissions. We know what this is, that is. Okay, set UID is used. This behavior described above is modified so that when an executable is launched, it does not run with the privileges of the user who launched it, but with the file of the owner. So for example, if an executable has a set UID bit set on it, and it's owned by root when launched by a normal user, it will run with root privileges. It should be clear why this represents a potential security risk if not used correctly. An example with a set UID permission is password. This utility can be used to change your login, and we can verify by using the ls command. So when you run the password command as a regular user, it will act as the root user because that root user owns it. So, but it's not running as you. Does that make sense? That's why you're able to change your password. And also it has execute permissions on the end for group and other. But it's run as is because that because the ID, the group ID, execute permission is set. That's where that one is. You're able to, is that right? Am I saying that right? Make sure I'm saying that right. Special permission, yep. Execute as the group that owns the file. Files, newly created directory, blah, blah, blah. And then file execute as the user that owns the file, not the user that ran it. Yeah. So the SUID. So the user owns the file right here. And it's set on the user, the permission, the SUID is set here. So now when you run it as that regular user, it's looking at it as the root user is actually running it, not you, the regular user. And then down here, we set permissions on the group. So here it says this, the set GID bit has effect on both files and directories. In this case, if the bit is set when executed, instead of running the privileges of the group of the user who started it, runs with those of the group which owns the file. In other words, the group ID of the process will be the same of that as the file. So it's actually on the group. And they walk through some more examples here on setting sticky bits. But those are the permissions. That's how you, that's gonna probably be a big one on the exam. Because you can actually combine these and do, let me see. I used to know these off the top of my head. It's been a minute since I did them. Right here. Okay, so if I went here and I'm gonna do Chmod 6755 on hello me. What do you think I'm gonna get? So see, this is when you start playing around with it. We know it's 4.
So you're setting S
and 1. So
and
9 times out of 10, I'm changing the last octet of this. If I did a 7 on that, what else is going to change? The last octet. So now I set the sticky bit. If I want to get out of that and I just want to go back to just having the sticky bit on the if I want to just change the group, we know the group is 4, right? User group, no, group is 2.
Group is 2, right?
Is that right? Yep. If I want to change the permission on the user, if I just want if I want the user and the other, want the user and the other, I can do 4 and 1, so that'd be 5. So now I got that set and the sticky bit. So you can play around with these permissions, right? And there is a matrix out there for set UID and GUID. Set UID. Let's do a matrix. Let me go to images. Because they break down each one of these numbers and what do they do. I had to look for it. I used to have one, like what does the 644 do? What does 544 do? What does 744 do? Or 755? And what does that look like? How does that affect my users when they log in? Because this can affect the users when they log in, how they run scripts and so forth. I had to find that it's a whole matrix for this. Let me see. Yeah, we'll go over this some more tomorrow. And we'll work with playing around with UMask and how that affects when you log in and what does it do. And I think you got an idea from tonight on what that looks like. I want to stop recording.